In part B, we are given with a triangle ABC. And we know that AB is the vector U, and AC is the vector V. It is also known that the dot product of U and V is 3, and that the triangle of ABC is the square root of 6, and we need to calculate first the cross product magnitude. Okay, so I will put here the angle alpha between the vectors U and V, and the area of ABC can be written down as U magnitude times V magnitude times the sine of the angle between them over 2. So this is just the trigonometrical formula for the area of a triangle. And this equals the square root of 6 from here. So I can also write that U magnitude times V magnitude times the sine of alpha is 2 times square root of 6, and this is exactly the definition for U cross V. So this is part 1. Now in part 2 we have to calculate the magnitude of U. So for that I'm going to use what we showed in A. This identity. So it was U dot V square plus U cross V square equals U magnitude square V magnitude square. Now I know that U dot V is 3, it is given, and we just showed that the product of the cross product of U and V is 2 times square root of 6. This now equals the magnitude of U square, magnitude of V square. But I can also know here the magnitude of V. So V was the vector here between the points C, which is 3, 2, 1, and A, which is 0, 1, 2. Yeah, this was given here. So I can take the distance between the points C and A and calculate the length of V. So it will be 3 square plus 2 minus 1 square plus 1 minus 2 square. And of course the square root of that, and this gives square root of 11. So now I can move on. I get here 9 plus 4 times 6 U magnitude squared times 11, and from here I can get that U squared equals 3 and U is the square root of 3. So this is part 2. Now Now for part 3 we have to calculate P and Q. So again I had the triangle ABC, and point B had P and Q in its coordinate. And we also had a point here 0, 1, 2, and for C 3, 2, 1. And this was U and this was V. So I'm going to write down the length of AB, which is U. This will be P square plus Q minus 1 square plus 3 minus 2, which is 1 square. And this is the length of U. So the length of U squared was 3. And now I will also use the fact that the dot product of U and V is 3. So if I write down the vector U, yeah, it's the vector AB, so it is P Q minus 1, 1. This is the vector U, and dot. Now I'll write the vector V. So it's 3 minus 0, it's 3, 1, and negative 1. This equals 3. So basically I have here two equations with variables P and Q, and I'm going to solve. I will start with the second equation. I get here that 3P plus Q minus 1 is 3. And from here I can see that 3P minus 5 equals Q. So now I can plug it in here. So I get P square plus 3P minus 5 minus 1 square plus 1 equals 3. So here I will get P square plus, here I have 3P yeah, sorry, there is a small mistake here, so this should be minus Q. So 5 minus 3P is actually Q, and this now I have to plug in here, so it's 5 minus 3P minus 1, which is 4 minus 3P. So I get 16 minus 24P plus 9P squared plus 1 equals 3. And this is just a quadratic equation. And the solutions are P1 is 1 and P2 is 7 over 5, and I had here the connection between Q and P, so Q is 5 minus 3P, and therefore Q1 is 2 and Q2 is 0.8. So those are the possible values of Q and P.